Algebra 2 Cram, New York State Algebra 2 Regents, Common Core, Key Facts, Trigonometry, the Ambiguous Case, Question 7, the Law of Sines. A over the sine of A is equivalent to B over the sine of B is equivalent to C over the sine of C. Now, the odds of someone doing exactly what you tell them to do is pretty slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. So inbox me at memedicine@gmail.com and definitely spread the words to your classmates and friends who also need to cram for Algebra 2. Inquire about other subject areas. Let's delve into the question. Review question 7. How many distinct triangles can be formed if the measure of angle A is 30 degrees, side B equals 12 arbitrary units that is, and side A equals 8? Is it going to be 1, 2 triangles that is, 3 triangles, or 4 0 triangles? Definitely press pause and take a moment to figure out your solution. All right, hopefully by now you are able to arrive at a solution, and if not, that's totally fine. Let's work through this together. Okay, so the first step that you're going to take is you're going to draw a rough diagram, and you need not worry about scale or accuracy for this rough triangle, okay? So here we have a triangle. You can draw it any which way you want, but I'm just going to try to draw it in proportion to the information that we're given, okay? So we know the measure of angle A is basically 30 degrees, okay? And then we're also told that we have a side B, which is 12 units. So side B would be the side opposite of angle B, okay? And then we're also told that 8 is the measure of side A, which opposes angle A. And then we have C left to figure out basically both the angle and the side, okay? But before we get into solving, we need to just conceptualize what this is in our mind. This is what we call in trigonometry and algebra 2 the ambiguous case. Basically, if two sides and one non-included angle, when I say non-included, I mean the angle doesn't fall between the known sides of a triangle are given, therefore either 0, 1, or 2 triangles may be drawn to fit this given data, okay? So automatically right away, we can eliminate answer choice 3 because, as I just said, with the ambiguous case, only 0, 1, or 2 triangles can be drawn. All right. All right, so now let's get into solving. And the first law that we're going to use is the law of sines, which says, you know, that the measure of side A over the sine of A is equivalent to the measure of side B over the sine of angle B, which is also equivalent to the ratio of the measure of side C over angle C. Okay, so we know our A and we know side B, so we can immediately figure out the sine of B. And let's evaluate this by cross multiplying. And when we do that, we get that 8, the sine of B, is equivalent to 12 times the sine of 30 degrees. And you should automatically know by now that the sine of 30 degrees is 1 over 2, or 0.5. So if you need your calculator to evaluate this, be sure that you're in degree mode, okay? And if you don't know how to set your graphing calculator to degree mode, just inbox me and I can give you pricing and ordering instructions for videos that demonstrate how to do just that, okay? All right, so when we further simplify this expression, we're going to get, when we divide both the left-hand side and right-hand side by 8, that the sine of b is equivalent to 12, the sine of 30 over 8, which ultimately yields a value of 0.75. So the sine of b is 0.75, okay? And this is about right for the value of sine, because I think it falls between 1 and all the way down to -1. All right. Okay, so here's where the ambiguity sets in. Since the value of the sine that we got for b is positive, there are two possible angles that this can be related to, and they occur in quadrants 1 and quadrant 2. Let me show you exactly what I mean when, by demonstrating with a Cartesian coordinate plane, okay? So basically, we know that at least one of the angles are acute because the sine of any angle theta is equivalent to y, that is the y coordinate, divided by r, which is sometimes called the hypotenuse if you were to imagine a triangle being formed by stepping to the right and going up, okay? So yeah, the slope could be reimagined as a triangle. And acute angles in quadrant 1 are in what we call standard position. That means their vertex is at the origin at 0. One ray, the initial side, lies on the positive x-axis, and the terminal side ray, is somewhere within the area of quadrant 1. Okay, so this is basically standard position. So when we have a quadrant 1 angle, which is always going to be acute, because you have to remember that the bounds of the angles in quadrant 1 is between 0 degrees and 90 degrees, and the definition of an acute angle is any angle less than 90 degrees, but greater than 0. So they're going to be acute, positive, and it just has a positive initial side on the x-axis. So this is what we call a reference angle. And a reference angle is theta, but more specifically, the positive acute angle made with the x-axis, okay? So there's no special thing that you have to do to figure out the trigonometric functions when you use your calculator to figure out angles that occur in quadrant 1, because what your calculator will always do, if you're using the inverse trig functions like inverse cosine, inverse sine, inverse tangent, they're always going to give you the answer that is the reference angle. So that's exactly what you're going to do, basically, in order to figure out the actual angle. You're going to have to use the inverse trig function, but we're not there just yet. So let's also take a look at quadrant 2, okay? So here we are using our inverse sine function because we're left with the sine of b is equivalent to 0.75, and when we do the take the inverse sine, we undo the sine function. So let me just cross that out to show you what I mean. This gets undone and it leads us over here to b, or you can denote this, the measure of angle b is equivalent to the inverse sine of 0.75, and from there what we're going to get is the reference angle, or the acute angle, 48.59 degrees. Okay, let's just highlight that really quickly. And this would be like a possible theta in here. So not only is this the value, one of the possible values that have a sine of 0.75, it's also the reference angle that occurs in quadrant 1. Okay, but what about Quadrant 2, because that's also a possible region where the sign is positive. And do you want to know why this is? Because remember, if you were to reimagine this ray in terms of its x and y steps, you would take, a step to the left on the x-axis and a step up in the direction of parallel to the y-axis. And remember, the sign of the angle theta is equivalent to y over r. So although our x-axis over here is negative, the y value is going to be positive, and r, the measure of the ray, is always going to be positive. I think I've neglected to say that because you're not looking at the coordinate, you're actually doing like a distance formula to get the value of r, okay? So this is just a really long aside to explain why there are two possible values that have a positive sign value, and it's based on the right triangle concept using the Cartesian coordinate plane, okay? So here goes our theta reference, which would be 48.59. It's the acute angle made with the, well, on this side is the negative axis. So the acute angle made with the x-axis is going to be 48.59, but our actual theta in this quadrant is 90 degrees plus this region. And you have to recall that the sum total of degrees between quadrant 1 is 90 and then 180. So obviously what we're going to do to find out theta is basically subtract the reference angle from 180 degrees, because that's our sum total of degrees in quadrant 2, and you're going to find out the rest of this, okay? Find out what this is. All right, so hopefully that clarifies things, or hopefully I didn't confuse you even more. So now we're ready to basically increase our awareness that there is another angle in quadrant 2 with the same value for sine as 48.59 degrees, which occurs in quadrant 1. Okay, so if angle B is acute, then it's going to be 48.59. But if angle B is basically obtuse, we have to use the quadrant 2 formula to figure out the angle measurement, which is 180 minus 48.59 degrees, okay, minus our reference angle, and that's going to yield a great answer of 131.41 degrees. So this angle here, if this reference angle were 48.59 degrees, this angle would be 131.41 degrees, okay? All right, so moving right along. Now we have to solve our ambiguous case. And the first case, like I previously mentioned, is if in fact the angle is the acute angle that we would find in quadrant 1, then our triangle would have the measurements. Well, we're now figuring out the measurement of angle C, whether that's possible or not. So it would be 180 minus 30 degrees minus 49 degrees. And we're going to get that angle C has a measurement of 101.41 degrees in this scenario. Let's say this answer was negative. That would mean it's not a possible triangle, okay? Now, if angle C is obtuse, we would have to subtract 30, because it's a measure of angle A, from 180, and also subtract 131. This was our obtuse answer. Okay, and then we would get that angle C has a value of 18.59 degrees, okay? And the reason why we're subtracting from 180 here is different from here, because the internal angles of a triangle, they should always sum up to 180, else I'm not really sure what kind of shape you have, okay? Therefore, there are two possibilities, because all three of these angles can occur. So this can occur with this, can occur with this, as well as this could occur with this, could occur with this, okay? The correct answer choice is going to be answer choice 2. There are 2 possible distinct triangles with the given dimensions in the question stem. All right, thanks for tuning in.